All right. Back in the first year introductory economics course, you learned how the demand and supply determines the price in equilibrium in a perfectly competitive market. Today, we take this demand theory to the data and try to estimate the slope of demand curve. It turns out that simply regressing the quantity of a product on its price does not really work here due to something called simultaneity bias. And you will see how the instrumental variable approach solves this issue of simultaneity bias to recover a demand function. Before we start talking about how to estimate the demand, let me talk a little bit about why we might want to estimate demand. It turns out that the shape of the demand function tells us a lot about welfare. The curvature of demand is often summarized by elasticity. And there are two types of demand elasticities: on price elasticity and cross price elasticity, which we are going to cover later in the course. And here we focus on price elasticity of demand. Now, what is on price elasticity? On price elasticity of demand, denoted by mu here, is defined as the percentage change in the quantity demanded given 1% increase in on price. Now, why is on price elasticity so important? On price elasticity is important because, for example, it tells about firms' market power. If you think about a monopoly's profit maximization condition, you can see that firms' markup is directly related to on price elasticity of demand. The markup equation on the slide says a monopolist markup is inversely related to the firm's product's own price elasticity of demand, which suggests that the monopolist markup is large if the demand for the product is inelastic. This should be intuitive because inelastic demand implies that consumers cut back in consumption when the firm raises the price. And so the firm can bid up the price to make a large markup. Anyways, in general, the welfare effect of any event depends on the on price elasticity mu. There are many ways to specify the demand function, but most typical demand specifications are the linear and log linear specifications. Linear demand specification is very simple. It says that quantity cap Q is linearly independent on its own price cap P. Here, A and B are the demand intercept parameter and the demand slope parameter respectively. Note that on price elasticity under the linear demand specification depends on on price cap P and quantity cap Q. In particular, the on price elasticity is increasing in the price and decreasing in the quantity. You should be thinking if this property of linear demand function makes sense. Now, log linear demand specifies the log of quantity as a linear function of log of price. Here, the parameter B is exactly the on price elasticity of demand, and so the log linear demand specification implies constant on price elasticity. Let's take a look at an example. Suppose that we want to estimate the demand for some homogeneous product, and there are cap J geographically isolated markets. For simplicity, assume that the markets are perfectly competitive. We have data on the price, quantity, and the price of input to produce final product for each market. So if the output is coffee, then input price in this case can be the price of coffee beans. Suppose that the demand for the product in market J is given by a linear function of own price and an unobservable, which is assumed to be independently and identically distributed across markets. This unobservable epsilon captures everything that is not observed by the researcher and affects demand for the product. And so it is called unobserved demand. Now, suppose that the supply of the product is given by a linear function of quantity produced and the price of input. Here, the unobservable U captures every unobserved supply factor or unobserved production cost. The coefficient parameters alpha 1 and alpha 2 are both expected to be positive if the marginal cost of production is increasing in output, and also the cost of production is increasing in input price. We are going to assume that input price is exogenous, such that variable Z is uncorrelated with unobservable U and also with epsilon. The system of equations pin down the equilibrium price and quantity. That is, solving the system of the two equations with two unknowns gives us the equilibrium price and the quantity as a function of exogenous variables of the model. In this case, these exogenous variables are input price Z, unobserved demand U, and unobserved production cost U. Let's first see that the OLS of quantity on the price does not allow us to recover the demand coefficient beta 1, given the demand and supply interaction. To see this, let us consider the covariance between the price and unobserved demand in the demand equation. If these two variables are uncorrelated, then the OLS of quantity on the price consistently estimates beta 1, and non-zero correlation implies that OLS does not consistently recover beta 1. To see that the price is correlated with unobserved demand, let's first substitute the price with the supply function. We know that the covariance between the constant and the random variable is 0. We also know that input price Z is exogenous and uncorrelated with unobserved demand. So the covariance between the price and unobserved demand is simply the product of alpha 1 and the covariance between the quantity and unobserved demand epsilon. Now, let us again substitute the quantity with the demand function. Then we see that we can decompose the covariance between the quantity and unobserved demand epsilon into two covariances. One, the covariance between price and epsilon, and two, the covariance between epsilon and epsilon. Note here that the covariance between epsilon and epsilon is simply the variance of epsilon, which is always positive. Now we have covariance between the price P and epsilon on both sides of the equation. Simplifying this equation shows that the covariance between the price P and epsilon is positive if alpha 1 is positive, such that marginal cost of production is increasing in output, and if beta 1 is negative, such that the demand is downward sloping. So we conclude that OLS of quantity on the price does not recover the demand slope consistently. Now, what is the intuition for this result? Basically, the price and the quantity are jointly determined by the demand and supply interaction. And so the variation in the price and the quantity captures two different movements. One, the movement in the quantity along the demand curve, and two, the shifts in the demand curve. What we want to capture is the movement in the quantity along the demand curve, but it is confounded by the shifts in the demand curve. When the demand shifts out as a result of positive demand shock, this implies a higher price, and so regressing the quantity on the price captures this variation in the price, which has nothing to do with the slope of the demand curve. Now, let me explain graphically how the bias is generated. Let's take price on the vertical axis and quantity on the horizontal axis. It doesn't matter whether you take price on the vertical axis or on the horizontal axis. Now, these dots here correspond to the data. And so here is the price and quantity in market 1. And here is the price in the market 2 and quantity in market 2 and so on. Now, the model says that these dots, these prices and quantities are generated by the intersection of demand and supply curve. Okay, so here is the demand in market 1, demand in market 2, and so on. Similarly, here is the supply in market 1, supply in market 2. Okay. Now, let me erase this graph and redraw exactly the same one. Now, if you run a regression of price on the quantity, how does the fitted OLS line look like? Okay. It will probably look like this. Because it minimizes the sum of squared residuals. Here is the residuals you had, let's say. Now, does that look like a demand curve? No, it doesn't even look like a supply curve. And so if you simply run a regression of price on the quantity or quantity on the price, then you don't get the demand curve. Okay. Now, what is the source of the problem? The source of the problem here is that unobserved demand shock epsilon is basically shifting the demand around. Okay, so, and this is basically preventing us from tracing out the demand curve.